Okay, let's go. Number 1. The Denisova Cave Bracelet. In 2008, a fragment of polished stone turned up in a Siberian cave, in sediment sealed since before modern humans existed in the region, and the drilling precision on it predated everything else in the record by 25,000 years. A team from Russia's Novosibirsk Institute of Archaeology and Ethnography had been excavating the East Gallery of Denisova Cave deep in the Altai Mountains. They were working Layer 11, a deposit so ancient that nothing in it had been disturbed since before anatomically modern humans arrived. The fragment they pulled was dark green, its surface smooth, unnaturally smooth, finished to a degree that didn't match anything they expected at that depth. It had been rasped, ground, and then polished with what the analysis later described as leather or a comparable fine-grained abrasive, the same sequence of finishing steps you'd see in a modern lapidary workshop. The stone was chloridolite. That identification alone created a problem, because the nearest known deposit of chloridolite sits more than 125 miles from Denisova Cave. Someone had carried that stone across the Siberian landscape, or traded for it, or moved it through a network of exchange routes that had no business existing at the age those sediments suggested. The team cleaned the fragment, photographed it under magnification, and that was when the object stopped making any sense at all. It had a hole drilled through it, not a rough puncture from a hand-twisted point, not the kind of angular groove you get from repeated manual boring with a sharpened stone. This was a clean, round, smooth-walled hole with minimal wobble, the kind of precision that comes from high-speed rotational drilling on a fixed axis. A tool spinning at sustained RPM, with the workpiece held stable. That technique is Neolithic technology. It has no precedent at this depth, in sediments that predate any era where it should exist. The layer the bracelet came from dates to a minimum of 40,000 years ago. Depending on the method applied to the surrounding sediments, the range extends to 65,000 or even 70,000 years before present. At the upper end, that would make this bracelet older than the earliest cave paintings in Europe, older than the oldest known musical instruments ever recovered. Derivianko and his colleagues published the initial findings in Archaeology, Ethnology, and Anthropology of Eurasia in 2008. The drilling precision was confirmed. The multi-stage polishing process was confirmed. The long-distance material sourcing was confirmed. No comparable artifact from this time period has been found anywhere else on Earth. It sits alone in the record, with no predecessor and no parallel. But here's the detail that everyone missed at the time. The makers of this bracelet were not Homo sapiens. Layer 11 of Denisova Cave is the deposit that gave the Denisovans their name. At the time the bracelet was found, we knew almost nothing about this species. A finger bone recovered from the same cave, in the same layer, a few teeth. That was essentially the entire fossil record. We didn't know what they looked like. We couldn't reconstruct their faces from what had been recovered. DNA sequencing by Svante Pääbo's team at the Max Planck Institute confirmed them as a distinct hominin lineage, separate from both Neanderthals and modern humans, a species that had shared the planet with us for tens of thousands of years before vanishing entirely. We know them from a finger bone, a few teeth, and this bracelet. And the bracelet, with its precision drilling and its polished stone, hauled 125 miles across Siberian terrain, is by far the most sophisticated artifact they left behind. And no, I'm not making that up. A species we can barely identify produced a polished stone bracelet using manufacturing techniques that have no business existing at that date. The raw material traveled more than 125 miles to reach the cave, which means either sustained long-distance travel or organized trade routes at a date when the standard model doesn't account for anything close to that level of coordination. Archaeology magazine ran a feature on it in 2015. The artifact is confirmed, the provenance is confirmed, and the question it raises hasn't gone anywhere in the years since. Now, before I move on, there's something I want you to keep in mind for the rest of this video. In 1976, NASA landed 2 spacecraft on Mars and ran what should have been a routine atmospheric test. The instruments measured the Martian atmosphere gas by gas, isotope by isotope. When the results came back, one number was wrong, not slightly off, not within instrument noise. Wrong in a way that, on Earth, would be produced by only one specific process. That measurement is the last item on this list. We'll get there. The bracelet is 40,000 years old, and it breaks the timeline for precision drilling by 25 millennia. But this wasn't just about one bracelet in one cave anymore. There's a site in the Czech Republic where a completely different technology appears 29,000 years ago, gets used for thousands of years, produces over 2,300 fired clay fragments, and the oldest known ceramic object on Earth, and then disappears from the record for the next 15,000 years. Not replaced by something better, not abandoned gradually, just gone. And nobody has ever been able to explain why. Number 2. The Dolni Vestonice kilns. In the 1920s, archaeologists working a hillside in Moravia, in what is now the Czech Republic, began excavating a site that didn't look like much from the surface. The terrain was rolling grassland, unremarkable, the kind of ground that gets farmed over and forgotten for centuries. What they found underneath was an Ice Age hunting camp occupied between 29,000 and 26,000 years ago, during a period when most of Europe was locked under glacial conditions, and the people living on its margins were supposed to be doing one thing: surviving. What they were actually doing was firing clay. The site contained 2 kilns, not hearths, not accidental fire pits where clay happened to get cooked by proximity to a campfire. These were purpose-built structures designed to reach and sustain firing temperatures between 930 and 1470 degrees Fahrenheit. Around and inside them, the excavation teams recovered over 2,300 fragments of fired clay and more than 7,000 ceramic pellets. The sheer volume rules out a one-time experiment. This was sustained production over generations. Among the fragments was a small figurine depicting a female form fired in clay and recovered intact. It's called the Venus of Dolni Vestonice, and it is the oldest known ceramic object in the world. I mean, think about that for a second. The next oldest ceramics in the archaeological record are the Jomon pottery from Japan, dating to roughly 14,000 BC. That means the people at Dolni Vestonice were firing clay a full 15,000 years before anyone else on the planet figured out how to do the same thing. That's not a gap. That's a canyon in the timeline that no model of cultural evolution has been able to bridge. In 1989, Pamela Vandiver and her colleagues published a landmark study in Science, Volume 246, analyzing the ceramic assemblage from the site. The paper confirmed the firing temperatures, confirmed the kiln construction, and then reported something that changed the reading of the entire excavation. Over 52% of the clay fragments showed thermal shock fractures. Not accidental breakage from poor technique, not the kind of cracking you get from uneven cooling or a badly mixed batch. Thermal shock fractures are what happen when you deliberately introduce a cold object into extreme heat, or yank a hot object into cold air. The ceramics were being exploded on purpose. Vandiver's team proposed that the firing at Dolni Vestonice wasn't utilitarian at all. The people at this site weren't making bowls or storage vessels. They were making figurines and then blowing them apart in the fire, possibly as part of a ritual performance, possibly for the sound and spectacle of the explosion itself. A technology invented 15,000 years ahead of schedule and used not for anything practical, but for something closer to theater. Here's the part that almost nobody talks about. After Dolni Vestonice, ceramic technology disappears from the archaeological record. Completely. For 15,000 years, the kilns go cold. No other site in Europe, Asia, Africa, or the Americas produces evidence of fired clay for the next 150 centuries. When ceramics finally reappear with the Jomon tradition in Japan, around 14,000 BC, there is no identifiable connection to the Moravian site. No transmission chain, no intermediate culture carrying the knowledge forward, no stepping stone between the two. The technology was invented, used intensively for roughly 3,000 years, and then the entire concept vanished from human civilization for longer than all of recorded history. That is one of the longest technology disappearances ever documented. Technologies get refined, they get replaced by something better. They get carried by migrating populations to new regions. They don't just evaporate for 15 millennia and restart from scratch on the other side of the planet. But this one did, and no model of technological transmission or cultural evolution has produced a convincing explanation for why. The kilns are real. The ceramic fragments are in museum collections across Europe. The Venus figurine has been analyzed, documented, and published in one of the most respected scientific journals on Earth. The evidence is not in dispute. What's in dispute is everything the evidence implies, because nobody has figured out how a 15,000-year blank in the record is even possible. A 15,000-year gap in ceramic technology is strange enough, but the next item pushes the clock back to 300,000 years ago, to a time before our species existed. And the objects it left behind have the exact same weight distribution as modern competition javelins. Whatever made them understood aerodynamics, understood material selection, understood multi-step manufacturing processes that leave tool marks we can still read today. And it wasn't human. Number 3. The Schoningen spears. In 1994, an archaeologist named Hartmut Thiem was working in an open-cast coal mine in Lower Saxony, Germany, when he found something that shouldn't have survived. The mine at Schoningen had been cutting through layers of ancient peat for years, and the waterlogged conditions had done something remarkable. They had preserved wood. Not petrified wood, not mineralized impressions, not the faint outlines that wood usually leaves behind after a few thousand years. Actual organic wood, testable, datable, still holding its original structure, in a layer of sediment 300,000 years old. What Thiem pulled from that peat was a spear, then another, then more. Over the course of the excavation and the decades of analysis that followed, his team documented 187 separate wooden artifacts, including more than 10 complete spears and 7 throwing sticks. Some of the spears measured up to 7.5 feet long. They had been shaped from spruce, a specific tree species selected for its straight grain and consistent density along the shaft. The knots had been removed. The surfaces had been scraped, seasoned to reduce moisture content, and then sanded smooth. That's not a typo, by the way. Sanded 300,000 years ago. The wood selection alone tells a story. Whoever made these weapons didn't grab the nearest branch and sharpen the end. They identified a tree species with the physical properties they needed, harvested it, and then processed the raw material through at least 4 distinct manufacturing stages, each one requiring a different tool and a different technique. That is, multi-step manufacturing with material selection. That is, engineering. And then there's the balance. The center of gravity on the Schoningen spears sits in the front third of the shaft. If you're not familiar with javelin design, that number is the one that matters. Front-loaded weight distribution is what gives a throwing weapon its flight stability, its range, and its accuracy on release. It's the same balance point used in modern Olympic competition javelins. A study published in Scientific Reports in 2019 tested replica spears, built to the Schoningen dimensions, and threw them under controlled conditions. They performed as functional long-range projectile weapons with effective aerodynamic properties. The Schoningen weapons performed as flight-stable projectiles designed by someone who understood how a thrown object behaves in the air. What comes next is the part that still doesn't make sense. In 2024, a team led by Nicholas Konrad published a comprehensive analysis of the full Schoningen assemblage in PNAS, Volume 121, Issue 15. The paper didn't just confirm what Thiem had found 3 decades earlier. It went further. The double-pointed throwing sticks, which had been partially overlooked while the spears got most of the attention, showed the same multi-step processing: scraped, seasoned, sanded to a smooth finish. Konrad's team used the phrase advanced wood processing techniques to describe what was happening at this site 300,000 years ago. And the paper closed with a statement that carries more weight the longer you sit with it: that the cognitive abilities of the beings who made these weapons had been underestimated until now. Subscribe if you want to see what else they've been underestimating. The likely makers of the Schoningen spears were Homo heidelbergensis, or early Neanderthals. No hominin remains were recovered from the site itself, but the dating and the geography point to one of those 2 species, both of which occupied northern Europe during this period. Neither is supposed to have been capable of what these artifacts represent: multi-step manufacturing across 4 or more production stages, deliberate material science, aerodynamic weapon design with a center of gravity calibrated to match modern javelin specifications, forward planning complex enough to select a raw material for its specific grain properties, process it over days or weeks, and produce a finished weapon that flies true. The Smithsonian's Human Origins Program lists the Schoningen spears as one of the most significant reevaluations of early hominin capability in the archaeological record. The 2024 PNAS study made it official. What we thought we knew about who was capable of what and when does not hold. The timeline was wrong. 300,000-year-old javelin engineering is hard enough to explain on its own. But there's a site in southeastern Turkey where archaeologists found something that should have been impossible at 12,000 years ago. Buildings standing 23 feet tall, a functioning sewer system, over 100,000 beads, and more than 2,000 copper artifacts. The site is as old as Göbekli Tepe. And while the entire world was arguing about Göbekli Tepe, this one got almost no coverage at all. Number 4. Boncuklu Tarla. In 2008, a team from the Mardin Museum in southeastern Turkey was conducting an emergency archaeological survey along the proposed route of the Ilisu Dam, a massive hydroelectric project that would flood an entire valley in the Darjasit district of Mardin province. These surveys are standard practice before major construction in Turkey, and they're usually routine. The archaeologists catalog what's there, document what they can, and the bulldozers come through. That's how it normally goes. This time, the survey found something that stopped the timeline. Buried under the soil of the Dargasit Valley was a settlement dating to at least 12,000 years ago. Not a seasonal camp, not a scattering of hearth pits and animal bones. A permanent settlement with buildings standing roughly 23 feet tall, built from stone, with organized internal spaces, carved architectural features, and a drainage system that the excavation team eventually identified as a functioning sewer network. It dates to approximately 11,800 years ago, which makes it the oldest known sewer system in the world. The site is called Boncuklu Tarla, and if you haven't heard of it, that's the point. Boncuklu Tarla is contemporaneous with Göbekli Tepe, and its deepest layers may be older. Göbekli Tepe, discovered in 1994 and excavated by Klaus Schmidt's team from the German Archaeological Institute, has dominated every conversation about early Neolithic complexity for the past 2 decades. It's been on the cover of National Geographic, discussed in documentaries, cited in hundreds of papers. And it deserves the attention because Göbekli Tepe is extraordinary. But Göbekli Tepe is a ceremonial site. It has no permanent housing, no infrastructure, no evidence of year-round habitation. People traveled there for ceremonies, but nobody lived there year-round. Boncuklu Tarla is different. People actually live there, at the same date, with buildings, with sewers, with organized production at a scale that doesn't fit the standard model of what human societies were supposed to be doing 12,000 years ago. And the timing of what happened next? Almost too perfect. Excavations began at Boncuklu Tarla in 2012 under the direction of the Mardin Museum team. What they found as they went deeper made the site progressively harder to explain. Over 100,000 beads. Not a few hundred, not a decorative scattering. 100,000 beads, worked stone and shell, in quantities that imply organized labor operating at something close to an industrial scale. For a community that, according to the standard model, hadn't yet invented the concept of surplus. 100,000 beads, for a species that supposedly hadn't figured out organized labor yet. Then the copper artifacts started coming up, more than 2,000 pieces, at a date when copper working isn't supposed to exist in this region. The standard archaeological timeline places the beginning of copper metallurgy significantly later. Finding over 2,000 copper artifacts at a pre-pottery Neolithic site raises questions that the excavation reports have noted but not answered. And there were carved figures, scorpions, snakes, motifs that overlap directly with the iconography at Göbekli Tepe, 150 miles to the northwest, at the same date. The same symbolic vocabulary, appearing at 2 independent sites, separated by enough distance that the connection raises more questions than it settles. Archaeology magazine ran a feature on Boncuklu Tarla in November 2019. The Turkish Ministry of Culture issued press releases. The Mardin Museum published excavation reports. And then the conversation moved on. The reason is simple. Göbekli Tepe had already claimed the entire narrative. There was no room in the public imagination for a second site, especially one that complicated the story by being a permanent settlement instead of a ceremonial center. The headlines had already been written. Boncuklu Tarla arrived after the frame had been set. So the question underneath this entry goes further than one site. How many others are buried under valleys that were surveyed too quickly or not surveyed at all? Boncuklu Tarla was found by accident during a dam survey in a region that had seen minimal prior archaeological investigation. If this site had been 50 miles further from the dam route, we would never have found it. We would still be talking about Göbekli Tepe as if it were alone. Boncuklu Tarla was missed because it was standing next to something famous. The next item on this list has the opposite problem. It's the largest of its kind on the entire planet. It covers 1/6 of the Earth's surface. NASA used its shapes to design the heat shields for the Apollo command modules. And somehow, after more than half a century of looking, nobody has been able to find the hole it came from. Number 5. The Australasian tektite-strewn field. For thousands of years, Aboriginal Australians collected dark glass stones from the desert floor. Small, smooth, oddly shaped objects, some of them round and flat like buttons, others teardrop-shaped, others with flanged rims that looked almost engineered. The stones didn't look like anything else in the landscape. They were too smooth, too regular, too glassy. Different Aboriginal groups gave them different names and different uses, but the common thread across cultures separated by thousands of miles of desert was the same. These stones came from the sky. In the 19th century, European scientists started testing them. What they found confirmed what the Aboriginal accounts had always said, and then went considerably further. The stones were tektites, natural glass objects formed when terrestrial rock is melted by the energy of an asteroid or comet impact and ejected into the atmosphere at tremendous speed. When the molten material cools during flight or re-entry, it hardens into glass. Tektites aren't rare. They've been found on every continent. What made these ones different was scale. The Australasian tektite-strewn field is the largest of its kind on Earth. It covers Southeast Asia, Australia, Antarctica, and the Indian Ocean floor. The total area of distribution is roughly 1/6 of the planet's surface. Approximately 790,000 years ago, something struck Earth with enough force to scatter molten glass across a swath of the globe, stretching from Tasmania to Southeast Asia to the Antarctic ice sheet. No other known impact event in the last million years comes close to that footprint. But the version you've heard probably stops there. Here's where it gets stranger. Some of the tektites, the ones found in Australia specifically, are called australites, and australites have a shape that no other tektites share. They're flanged buttons, flat, circular glass objects with a raised rim around the edge, formed not during the initial ejection, but during a second event, atmospheric re-entry. These pieces of molten glass were launched with such force that they left the atmosphere entirely, flew through space on a ballistic arc, and then fell back to Earth. During re-entry, the leading edge melted again, flowing backward around the rim in exactly the way aerodynamic models predict for an object falling through the atmosphere at hypersonic speed. The shapes are so precisely sculpted by the physics of re-entry that NASA used them as reference models when designing the heat shields for the Apollo command modules. That's not an exaggeration, by the way. NASA engineers studied australite shapes to understand how materials behave during atmospheric re-entry. Glass objects, formed by a 790,000-year-old impact, gave the Apollo program data on heat shield geometry. And here's the part that should have been resolved decades ago but hasn't been. The source crater has never been found. An impact powerful enough to eject glass into orbit and scatter it across 1/6 of the Earth's surface should have left a crater roughly 9 miles across. That's not a subtle feature. That's a hole in the ground the size of a small city. 4 of Earth's 5 major tektite-strewn fields have identified source craters. The North American field traces to the Chesapeake Bay impact structure. The Central European field connects to the Ries crater in Germany. The Ivory Coast field links to Lake Bosontui in Ghana. The Australasian field, the largest and youngest of them all, has no confirmed source. In 2020, Carey C. and colleagues published a paper in PNAS proposing that the crater sits beneath the Bolivian Plateau in Laos, buried under approximately 1,000 feet of basalt lava that erupted after the impact. The hypothesis is geologically plausible. The location sits within the projected center of the strewn field. The lava cap could explain why no surface trace has been found. But there's a problem. Nobody has drilled to confirm it. No deep borehole has penetrated the basalt. No direct geophysical survey has imaged a crater structure at depth. The hypothesis exists as a model on paper, supported by surface evidence and strewn field geometry, but without the one piece of physical confirmation that would close the case. Other candidates have been proposed: the South China Sea floor, sand dune fields in China, none confirmed. After more than a century of looking, the hole that should be 9 miles across, the source of the largest tektite-strewn field on Earth, the impact event whose debris NASA used to design spacecraft, remains missing. The entire field is documented. The glass has been collected, tested, dated, and studied by dozens of research teams across multiple countries. The re-entry physics have been modeled. The Apollo connection is published. Everything about this event is confirmed, except the one thing you'd expect to find first: where it happened. And that Mars measurement I mentioned at the beginning? That's still ahead. An impact that covered a sixth of the planet, glass that NASA used to design spacecraft heat shields, and a crater that's been missing for 790,000 years. But the next item on this list didn't come from an impact. It came from somewhere else entirely. A pebble found in the Egyptian desert, small enough to hold in your palm, whose chemistry doesn't match anything on Earth, any known meteorite, or any other body in our solar system. Scientists think it might be a piece of a dead star. Number 6. The Hypatia stone. In 1996, a geologist named Ali A. Barakat was walking the Libyan desert glass field in southwestern Egypt, a region already famous for producing natural silica glass scattered across the sand by an ancient thermal event. The field has been picked over for decades by researchers, collectors, and the occasional tourist. Barakat found a small, dark pebble. It didn't look like the Libyan desert glass around it. It didn't look like the local sandstone. It didn't look like any meteorite he'd handled before. He collected it, logged it, and it sat in storage while the scientific pipeline did what the scientific pipeline does, which is move slowly. It took 17 years before anyone confirmed what Barakat had picked up. In 2013, a team at the University of Johannesburg ran a comprehensive analysis and published their findings. The stone was definitively extraterrestrial. That much they could prove. What they could not do was match it to anything. Not any rock on Earth. Not any class of known meteorite. Not any asteroid, comet, or planetary body in the solar system. It didn't fit. The stone was named Hypatia, after the ancient Alexandrian mathematician, and it was placed in a category of 1. But here's what the initial analysis didn't catch. It took another round of testing, years of additional work, before the real picture started coming together. In 2018, Balayanin and colleagues published a paper in Earth and Planetary Science Letters, reporting micromineral compounds inside the Hypatia stone that had never been observed before in any specimen on Earth. Nickel phosphide mineral grains with almost no iron. In every known context where you find nickel phosphide, you find iron alongside it. That's how the chemistry works in our solar system. In the Hypatia stone, the iron is essentially absent. Nobody had ever seen that combination before. The stone also contains microdiamonds, silicon carbide, and a carbon-dominant matrix, making up 74 to 77% of its total composition. Each of those components individually could be explained. Together, in those proportions, in that mineral context, they pointed somewhere no meteorite had ever pointed before. In 2022, Jan Kramers and his team published a study in the journal Icarus that laid it out. They measured the ratios of 15 key elements in the Hypatia stone and compared them against every known formation process in the solar system. Early solar nebula condensation, planetary differentiation, asteroid accretion, cometary nuclei. None of them produced the observed ratios. The one process that did match, the one model where all 15 elemental signatures lined up simultaneously, was Type 1a supernova nucleosynthesis. Think about what that actually means. A Type 1a supernova is what happens when a white dwarf star accumulates enough mass from a binary companion to exceed its stability limit and detonates. The explosion destroys the star entirely and scatters its processed elements into the surrounding interstellar medium. Those elements drift as dust through space, sometimes for billions of years, until they're swept into a forming solar system and incorporated into whatever accretes there: planets, moons, asteroids, and occasionally, small fragments that survive the entire process intact. If Kramers is right, the Hypatia stone is a piece of pre-solar dust, material produced by a star that exploded before our sun existed, before the planets formed, before the Earth was anything more than a disk of gas and rubble. The dust drifted into the solar nebula, got incorporated into the material that became our solar system, and somehow survived 4.6 billion years of accretion, bombardment, and geological recycling to end up sitting in the Egyptian desert, where Ali Barakat happened to walk past it in 1996. It would be the first tangible piece of a supernova ever held in human hands. The supernova hypothesis hasn't been independently replicated yet. Kramers published the elemental data. Other teams have confirmed that the stone doesn't match any known solar system source. But the specific claim that it formed in a Type 1a supernova awaits verification from a second independent lab. That's the standard, and the standard hasn't been met. What has been met is the baseline. The Hypatia stone is extraterrestrial, confirmed. It doesn't match anything in our solar system, confirmed. Its mineral chemistry includes compounds never observed in any other specimen, confirmed. And the one formation model that accounts for all 15 elemental ratios simultaneously is the thermonuclear explosion of a dead star. A stone that doesn't match anything in our solar system. But the next item on this list is a light. White, yellow, sometimes blue or red, appearing over a valley in central Norway, hovering above the terrain, splitting into pieces, and accelerating in ways that no aircraft can replicate. It has its own permanent research station staffed by a Norwegian-Italian-French collaboration. They've been pointing spectrometers and radar at it since the early 1980s, and they still can't explain what it is. Number 7. The Hessdalen Lights. In the early 1980s, residents of a narrow river valley in central Norway started reporting something they couldn't explain. Lights in the sky over the Hessdalen Valley. Not aircraft, not satellites, not the aurora, which doesn't reach that latitude with that appearance. These were discrete luminous objects, white, yellow, sometimes blue or red, hovering above the valley floor, drifting across the terrain at varying altitudes, sometimes splitting into multiple pieces, sometimes accelerating in directions and at speeds that no conventional aircraft could match. The reports weren't coming from one person or one household. They were coming from across the valley, from farmers, from families who'd lived there for generations. And they weren't new. Residents told researchers that similar lights had been appearing since at least the 1930s. In 1983, a group of Norwegian scientists decided to stop collecting anecdotes and start collecting data. What followed is the longest-running scientific investigation of an atmospheric light anomaly in history. A Norwegian-Italian-French collaboration established 3 permanent research stations in the Hessdalen Valley, equipped with cameras, spectrometers, magnetometers, VLF receivers, and radar. A permanent automated monitoring station went online in 1998 and has been recording continuously since. Every year, the collaboration runs field campaigns involving roughly 100 researchers, arriving with portable instruments, deploying additional sensors, and spending weeks in the valley attempting to capture and measure the lights in real time. 40 years of continuous, instrumented observation. That is not a rumor. That is a data set. The spectrometric data is where the mystery hardens. Optical spectrometry of the Hessdalen lights shows emission lines for hydrogen, oxygen, and nitrogen, a spectral signature consistent with plasma. The lights, whatever they are, contain ionized gas. Some readings also show traces of metal ions in the emission spectrum, elements that shouldn't be present in an atmospheric plasma at those altitudes. The lights have been photographed thousands of times. They have been tracked on radar. And the radar returns come from altitudes and positions where no solid object exists. What comes next is the part that still doesn't make sense. 2 leading hypotheses have been proposed. The first is that radon gas, seeping from abandoned mines in the valley floor, ionizes dust particles and creates luminous Coulomb crystals, essentially small, glowing structures of charged particles suspended in the atmosphere. The second is piezoelectric stress, the idea that tectonic pressure on the quartz-bearing rocks beneath the valley generates electrical discharges powerful enough to ionize the air and create visible light. Both hypotheses explain some of the observations, neither explains all of them. The radon model doesn't account for the radar returns at altitude, or for the metal ion traces in the spectrum, or for the observed behaviors, the splitting, the acceleration, the apparent directional changes that don't follow wind patterns or convection currents. The piezoelectric model handles some of the spectral data, but can't explain why the phenomena appear repeatedly in the same municipal and not in thousands of other locations with comparable geology. Massimo Teodorani, one of the lead researchers, published his analysis in the Journal of Scientific Exploration in 2004 and stated plainly that no single existing model accounts for the full range of observed phenomena. The lights are still appearing. The instruments are still recording. A paper published in the Journal of Applied Geophysics in 2024 analyzed recent data and confirmed what the collaboration has been saying consistently. The phenomenon is real, repeatable, measurable, and unexplained. 40 years of spectrometers, radar, cameras, magnetometers, and field campaigns by researchers from 3 countries. The data exists. The measurements are published. The phenomenon has been captured on every category of instrument the team has deployed, and after 4 decades, the explanation is still incomplete. Subscribe if you want to keep finding out what else has been sitting in the data. Now, everything on this list so far has been something that appeared when it shouldn't have, or something that disappeared when it shouldn't have. A bracelet too advanced for its era. Ceramics that vanished for 15,000 years. Javelins before humans existed. A settlement nobody noticed. An impact crater nobody can find. A stone from outside the solar system. Lights that no model can fully explain. But the next item flips the mystery in a different direction entirely. Something was built, on purpose, across an entire continent, and then left behind with nothing inside. 2,000 underground tunnels across Central Europe, too narrow to stand up in, with no artifacts, no tool marks, no soot, no remains, and no written record of who dug them or why. In an era when European monks documented practically everything. Number 8. The Erdstall tunnels. Imagine you're a farmer in rural Bavaria. You've been working the same property your family has worked for generations. One afternoon, a section of your field collapses into a depression that wasn't there before. You clear the debris and find a narrow opening in the earth, barely wide enough to fit your shoulders through. You lower yourself in. The passage goes down at an angle, not steep, not vertical, just enough to require crawling. At the bottom, the space opens slightly, but not much. The ceiling is 3.5, maybe 4 feet high. You can't stand. The walls are about 2 feet apart. The tunnel continues ahead of you into the dark, and at the far end, you can just make out a vertical slot in the wall, a narrow shaft going down to another level. You'd have to exhale to fit through it. There is nothing inside. No tools, no pottery, no bones. No scorch marks on the walls, no evidence that anyone has ever used this space for anything, and yet someone carved it out of the ground by hand. This is not one tunnel. There are roughly 2,000 of them. They're found across Bavaria, Austria, parts of France, Spain, and Britain. In Bavaria alone, over 700 have been documented. They're called Erdstalls, a German term that translates loosely as Earthstall or Earthplace, and they are one of the strangest construction mysteries in Europe. The dimensions are remarkably consistent across sites. The passages run roughly 2 feet wide and 3.5 to 4.5 feet high. The vertical connectors between levels are called Schlupfe, or slip passages, and they're exactly what the name suggests. Slots so narrow that an adult has to turn sideways, compress their chest, and slide through. These aren't comfortable spaces. They weren't designed for comfort. They also weren't designed for storage, because nothing was stored in them. They weren't designed for habitation, because you can't stand up, can't build a fire without suffocating, and the passages don't connect to any known dwelling site. Almost nobody outside of Central Europe has heard about these, and the reason is simple. There's nothing to report. No artifacts means no catalog. No catalog means no museum exhibit. No exhibit means no documentary. The tunnels are empty, and empty spaces don't generate headlines. Radiocarbon dating of organic material found in the tunnel walls places most of them in the 10th to 13th century CE. That's the European medieval period. The era of Romanesque cathedrals, of Benedictine monasteries, of the Domesday Book, of monastic scriptoriums that documented landholdings, property transfers, tax records, tithe obligations, and building projects with obsessive precision. If anything happened in medieval Central Europe that involved organized labor, stone cutting, and construction, there should be a record of it somewhere. There is no record, not one. No medieval text mentions building these tunnels, no church document references them, no manorial record allocates labor for their construction, no tax roll accounts for the effort. Zero documentary trace, in an era that documented practically everything it did. 2,000 tunnels, no records. In the century that invented bookkeeping, the leading hypothesis from the researchers who've studied them is that the Erdstalls served a ritual or spiritual function, possibly as symbolic rebirth passages where participants crawled through the narrow tunnels as an act of spiritual transformation, squeezing through the Schlupfe as a physical representation of death and renewal. Der Spiegel ran a major feature on them in 2011, and the ritual interpretation was the centerpiece. It's a reasonable hypothesis. It might even be right for some of them, but 2,000 of them? spread across 5 countries, all built in roughly the same period, with the same dimensions, using the same design, and then left empty with no explanation written down anywhere? A ritual that widespread should have left textual evidence. Religious practices in medieval Europe were documented, debated, legislated, and occasionally condemned in church councils. If thousands of communities across Central Europe were building underground passage networks for spiritual purposes, someone should have written about it. Someone should have argued about it. Someone should have banned it. Nobody did. Or if they did, the record hasn't survived. Which raises its own question about what kind of practice generates 2,000 physical structures and 0 written commentary. The Erdstalls are still there. You can visit some of them. You can crawl into the passages and squeeze through the schlupfe if you're willing. What you can't do is explain why they exist, because nobody who built them left a single word behind. 2,000 tunnels, nobody documented. But the next item makes the Erdstalls look recent. On the floor of the Atlantic Ocean, at a depth where sunlight never reaches, something has been printing the same perfect hexagonal pattern into the sediment for over 540 million years. Scientists first described it as a fossil in 1850. They photographed it alive on the deep-sea floor in the 1970s, and in all that time, nobody has ever seen what makes it. Number 9. Paleodictyon nodosum. In the 1970s, a deep tau camera system was being dragged across the floor of the mid-Atlantic ridge, more than 10,000 feet below the surface, in water so deep that sunlight hadn't touched the sediment in millions of years. The camera was there to photograph the seafloor geology, mapping the terrain for a routine oceanographic survey. When the images came back, the researchers found something nobody was looking for. Pressed into the mud, clearly visible in the camera frames, were hexagons. Not rough outlines, not vague geometric suggestions. Perfect hexagons, arranged in a repeating grid pattern, each one between roughly 1 and 3 inches across, with intersections meeting at precise 120-degree angles. The pattern was immediately recognizable because paleontologists had been looking at it in fossilized form for over a century. The same hexagonal grid had been first described as a trace fossil in 1850. It shows up in sedimentary rock from sites around the world, preserved in stone that dates back more than 540 million years to the early Cambrian. Geologists had been studying it, cataloging it, and debating what made it for generations. What nobody expected was to find the same pattern still being produced, alive and fresh, on the modern ocean floor. And here's where the timeline stops making sense. The hexagonal structures aren't just superficial impressions. When researchers examined them closely, using higher resolution imaging and sediment sampling from the mid-Atlantic ridge and other sites, they found a network of tiny vertical shafts, each about 1 millimeter across, connecting to a horizontal tunnel system running 2 to 3 millimeters below the sediment surface. The tunnels form the hexagonal grid. The vertical shafts connect it to the water column above. The architecture is consistent across specimens separated by thousands of miles and hundreds of millions of years. It's the same blueprint, from the early Cambrian to the present day. For 540 million years, something has been constructing the same precise hexagonal pattern on the deep ocean floor, using the same dimensions, the same geometry, the same subsurface tunnel network. The pattern has been found at the mid-Atlantic ridge. It's been found in the South Atlantic, off eastern Australia, in the Clarion-Clipperton zone of the Central Pacific. Wherever researchers look in the right depth range, 10,000 feet and below, the hexagons are there. 540 million years. The same pattern. Just sit with that number for a moment. That's a span of time that contains the entire history of complex life on Earth. Every animal that has ever lived, from the first trilobites to the dinosaurs to the first mammals to us, has existed within the window that this pattern has been running. And it is still running. Rona and colleagues published a detailed study in Deep Sea Research Part 2 in 2009, documenting the living forms. Durden and colleagues expanded the distribution data in marine biodiversity in 2017. A 2023 paper in Nature Scientific Reports confirmed new records in subarctic waters, further expanding the known range. Nobody has ever observed the organism that makes them, not once. In nearly 2 centuries of study, across dozens of research expeditions, with progressively more sophisticated imaging and sampling technology, no human being has ever watched a Paleodictyon pattern being constructed. No organism has been found inside one. No organism has been observed entering or leaving one. No DNA has been successfully extracted from the tunnel walls that would identify a maker. Two hypotheses exist. The first is that Paleodictyon is a trace fossil, a burrow system created by an unknown organism that excavates the tunnels and then either leaves or dies without being detected. The second is that it might be the compressed skeletal framework of a hexactinellid sponge, a glass sponge whose internal structure collapses into the sediment after death and leaves behind the hexagonal imprint. Neither hypothesis has been confirmed. Neither has a candidate organism. The trace fossil model requires a creature that builds identical architecture across every ocean basin for 540 million years and has never once been seen alive. The sponge model requires a species that has left no other trace besides the geometric pattern itself, no spicules, no organic residue, nothing except the grid. Whatever is making Paleodictyon nodosum has been doing it since before the first fish evolved, since before anything crawled onto land, since before plants existed on the continents. It hasn't changed its pattern. It hasn't adapted, diversified, or drifted from the original design. It has been executing the same precise geometry, in the same depth range, on every ocean floor that's been checked, for longer than any other continuous biological signal in the geological record. That's 9 items. A bracelet drilled 25,000 years too early. Ceramics that vanished for 15 millennia. Javelins before humans. A settlement nobody noticed. A crater nobody can find. A stone from a dead star. Lights that defy every model. Tunnels with no records. And hexagons that have been printing themselves into the ocean floor since before complex life began. Now, the 10th, the one I mentioned at the beginning of this video. In 1976, NASA landed 2 spacecraft on Mars and ran an atmospheric test. The number that came back was wrong. Here it is. Number 10, the Mars Xenon-129 XS. In July 1976, the Viking 1 lander touched down on Planitia, a broad plain in Mars's northern hemisphere. It was the first spacecraft to successfully operate on the Martian surface, and among its instruments was a mass spectrometer designed to measure the composition of the Martian atmosphere, gas by gas, isotope by isotope. The instrument ran its first sample. The readings came back, and one number was wrong. That's the measurement I told you about at the beginning of this video. The mass spectrometer detected a pronounced overabundance of Xenon-129 in the Martian atmosphere. Xenon is a noble gas, chemically inert, which means it doesn't react with other elements or get absorbed into rocks. Whatever xenon is in an atmosphere stays there, floating unchanged, essentially acting as a chemical record of whatever event produced it. Xenon-129 is a specific isotope, and it's produced by the radioactive decay of iodine-129, an unstable isotope with a half-life of 15.7 million years. All the iodine-129 in the solar system should have decayed within the first 100 million years or so after the solar system formed, which means all the Xenon-129 on Mars should have been produced during that early window and then stayed put. The problem is that Mars has far too much of it. The ratio of Xenon-129 to the other xenon isotopes on Mars is significantly higher than what early degassing models predict. If the Xenon-129 came from the planet's interior, outgassed during the early period when Mars was geologically active, the ratio should fall within a predictable range based on the planet's initial iodine-129 inventory. It doesn't. The ratio is too high. Viking measured it. And then, decades later, the Curiosity rover confirmed it. Same result. The Xenon-129 XS is real, reproducible, and it's not an instrument error. The conventional explanation has 3 parts. First, early degassing from Mars's interior released the iodine-129 decay products into the atmosphere. Second, over billions of years, the solar wind preferentially stripped lighter xenon isotopes from the Martian atmosphere, leaving the heavier Xenon-129 behind in disproportionate quantities. Third, the combination of these 2 processes, early production and selective loss, accounts for the observed ratio. The problem is that no single model has ever been able to account for all 3 variables simultaneously. The Xenon-129 enrichment, the depletion of lighter xenon isotopes, and the total abundance of xenon in the Martian atmosphere. Avis and colleagues published a detailed analysis in Earth and Planetary Science Letters in 2021 examining exactly this question. Each model explains one or two of the three variables. None of them close the loop on all three at once. And here's where the data takes a turn that sits outside the mainstream. When the Martian Xenon-129 ratios are plotted against nuclear fission event curves from Earth, the match is striking. The isotopic signature on Mars follows the same distribution pattern that appears in terrestrial environments where nuclear fission has occurred. That comparison is not speculation. It's published data, and the correlation is in the numbers. John Brandenburg, a plasma physicist, presented a hypothesis at the American Geophysical Union and at the 42nd Lunar and Planetary Science Conference in 2011, proposing that the Xenon-129 excess on Mars could be consistent with a large-scale thermonuclear event in the planet's past. The hypothesis is considered fringe. It has not been published in a top-tier planetary science journal, and it has never been formally disproven. No published rebuttal has demonstrated that the data Brandenburg cited is wrong. Swindle's review in Reviews in Mineralogy and Geochemistry acknowledges the anomaly. NASA's own JPL Curiosity data confirmed the measurements. The Xenon-129 excess is confirmed by every instrument that has ever measured it. The question is what produced it. Because the one explanation that fits all three variables simultaneously is the one that nobody in mainstream planetary science is willing to put their name on. That's the measurement NASA got in 1976. The same instruments that told us the composition of every other gas in the Martian atmosphere, the same data pipeline that produced some of the most important results in planetary science, returned a number for Xenon-129 that has resisted every conventional explanation for nearly 50 years. 10 entries, 500 million years, and every one of them is still open. If you've made it this far, you already know the list is not finished. Tell me in the comments which one you'd investigate first and where you're watching from. Subscribe if you want to keep finding out what else has been sitting in the data.